So welcome guys in a new video. In this video we are going to implement the neural network in Python, and the example will be here, the digit recognition, the simple one. So guys, let's start. So first step always is to import the dataset and see what's inside that dataset is. So I will attach the link below to download the dataset. So like first we will import the libraries which we need, such as import numpy, import pandas, import Segon as SL, and then import the matplotlib. Okay, so we imported those. So now the next step is to import the dataset that we have for training and testing. So for that we'll just do train df is equal to pd dot read csv, and then just give the path of that training file. For me it's like uh, and similarly import the test df on which we will predict. Okay, me is in the same path, so we'll use that only. Just do test.cs. So after importing the dataset, let's see what's inside the dataset is. I mean, just to analyze what are we going to do. So for that, let's see how many data records there in training dataset. So it's like 42k, and number of columns are 785. So let's just see what is the label of first data first data row. That's one. So let's see what that data look like. Okay, so it looks like this. So like 1 1. Okay, so that's good. So the next step will be to create our data set for training, and for that let's define x as from train df by taking all the columns except the last one, that is label. That is what we have to predict, and just take x is equal to 1, and then create a y as a train df, its label, which we have to predict. And after that definitely we have to split the data set, that is x, into some training and validation part. So for that we will use sklearn library, and here we have to split. After splitting the data set, we have the training and validation part. Now we will fit the model and test it. So after splitting the data into train and test, now we will make those train and test as a numpy vectors, so that it will be easy to input into CNN. So let's just name that into xtrain CNN equal to xtrain node to numpy. That will convert into numpy, but we will reshape into 28 cos 28 vector. So do that for x test also. Similarly, so just train to test, and again here x test. So everything will be same, just do that. So after making the input as the CNN bonds, now we will convert the this input and normalize it. So to normalize, just take it x train normal and just train to CNN and divide it by 255. So all the values are between 0 and 1. Similarly, do that for test data also. Okay, so after doing that for test data, just simply do the, so now it is normalized. Now just make your y train data as categorical. So for that, just do this thing. It will convert your y train into categorical values, so that it will be easier for CNN to process. So after making the x and y values, that is important for CNN to process, we are going to make our model. So we are making our model with the TensorFlow. So just import these libraries, and after that we will make our model. So we will just name our model as model, and from keras we will import the sequential, and in that the first one will be the input layer. So for that, just make the input as so we will give the shape. So we know already the shape is 28 cross 28 cross 1. And so after making the shape, after making the input, we will first make the layer. So the first layer will be convolutional layer, so conv 2D. So just give these inputs. So we will give kernel size, so the 50 will be the input size. Then kernel, just give the kernel size as 3 cross 3. And after giving this, just make sure that padding is there, and padding is there. After that, just make sure like we will have the activation function for that layer, so we will be using relu here. So after making those layer, so just after the output of that layer, just we will do the max pool for that layer. So max pooling. Okay, so after doing that, so similarly make one more layer. We'll be going to have one more layer for that. Okay, similar, and then just flatten this so that we will input this to simple neural network. Flatten the output, I mean. Okay, so after flattening the output, just have dropout, so dropout layer, so that there will be no overfitting. Okay, so in the dropout layer, just give 0.5 as an input, and then just have two layers that will be dense layer. So simple neural network, so for that just give dense and have the input as 1000 and an activation as relu. Okay, okay, then after that have one more layer, so that will be the output layer for us. uh, so for that just use softmax because we want to take output. Okay, so we will have this our model. So after that just run this. Okay, now we will have our model with us. So after making the model, we will just do model.compile to compile the model. So in that we should have to pass some arguments like optimizer. What optimizer should it use? So we'll use keras optimizers dot rms pro. Okay, so this is the best I use. Then what's the lowest function it use? So it also be from keras because we are using categorical. So we will use categorical cross entropy. Okay, and so the matrix it you should to compare is also from the keras, that will be categorical accuracy. Okay, so there is just an error. Instead of keras dot categorical cross entropy, just use keras dot losses dot cross entropy, and then just hit enter. So after making the model and compiling it, now it's time to fit the model with the data. So for that, just do model dot fit, and inside that just pass the parameter x train, that is x train normalize, and then y train CNN. Yes, y train CNN and x train normalization. After that, batch size, what the batch size you want, so let's make it 64. And what are the epochs, let's make it 15. And then validation split we want, yes, so validation split, so let's make it as 0.1. So if you see closely, there is an error because we want only 10 predictions, like 0 to 9. So but here we are giving 1000, so just make it 10 and recompile it. Okay, and then run dot fit model. So after running the model, we will get something like this, and this after this we will have our model fitted. Now we can test it over some test x test data that we just created, and by this, like, we can check the accuracy of our CNN model, and it is coming pretty well. There's approximately 99%. So this is how we create our model in Python, and you can implement in the same way for any other use case that you might have, or ask me in the comment section. We will provide you the instruction over there. Thank you.